Hello, and welcome to the September edition of the American Journal of Physiology Heart and Circulatory Physiology video table of contents, or from the editor's desk. This month, we have a very large issue that includes 6 outstanding reviews, 3 editorial focus articles, and 21 original research articles. Just a note that the issue is populated throughout the month and may even begin in the previous month in order to reduce the time from acceptance to publication. Here are some of the highlights that you'll find in the September issue. Moore et al. Review the role of bilirubin in cardiovascular regulation. Bilirubin, a potentially toxic catabolite of heme and indicator of hepatobiliary insufficiency, exhibits potent cardiac and vascular protective properties. Individuals with Gilbert syndrome may experience hyperbilirubinemia in response to stresses including reduced hepatic bilirubin excretion, increased red blood cell breakdown, and with individuals usually informed by their clinician that their condition is of little consequence. This review outlines the current knowledge of and the uses for bilirubin in clinical medicine and summarizes recent progress in revealing the physiological importance of this poorly understood molecule. Shakiri et al. Summarized current knowledge on cellular senescence and its secretory phenotype, which might be the missing link between aging and diabetes contributing to cardiovascular disease. They discuss the evidence that aging is a powerful, independent risk factor for cardiovascular diseases such as atherosclerosis and heart failure. Concomitant diabetes mellitus strongly reinforces this effect of aging on cardiovascular disease. Cellular senescence is a fundamental mechanism of aging and appears to play a critical role in the onset and prognosis of cardiovascular disease in the context of both aging and diabetes. Senescent cells are in a state of cell cycle arrest, but remain metabolically active by secreting inflammatory factors. Holzapfel and Ogden review vascular microstructure and the contributions of each of its components to overall mechanical behavior. They also describe the changes of the microstructure which occur as a result of abdominal aortic aneurysms and disease, such as atherosclerosis. They focus on how the passive and active constituents are incorporated into a mathematical model without going into detail of the mathematical formulation. Kloner et al. Review the no reflow phenomenon. This refers to the observation that when an organ is made ischemic by occlusion of a large artery supplying it, respiration of patency in that artery does not restore perfusion to the microvasculature supplying the parenchyma of that organ. They discuss the mechanisms of the no reflow phenomenon, including ultrastructural damage to the microvasculature, endothelial swelling, and inflammatory mediators in the heart and the brain. New guidelines suggesting that reperfusion for stroke may be considered as late as 24 hours after onset of symptoms suggest that clinicians may be seeing more no reflow in the future. Leon Pinnell and co-authors describe the Mouse Heart Attack Research Tool, or mHeart, which consolidates a large data set of over 10 years of experiments from their own laboratory in order for cardiovascular investigators to generate novel hypotheses and identify new predictive markers of progressive left ventricular remodeling after myocardial infarction in mice. They generated physiological, biochemical, cellular, and proteomic outputs from plasma and left ventricles obtained from both post-MI and no-MI naive control groups. They included both males and females mice ranging in age from 3 to 36 months old. mHeart 1.0 contains more than 888,000 data points and includes results from more than 2,100 unique mice. Lesniewski et al. Examined the glycocalyx in microvessels of young and old male C57 black 6 mice using intravital microscopy and transmission electron microscopy, and in the human participants using intravital microscopy. These ranged in age from 29 to 60 years. Glycocalyx thickness in mesenteric and skeletal muscle microvessels was 51 to 54% lower in old compared with young mice. They also observed 33% lower glycocalyx thickness in the sublingual microcirculation of humans with advanced age. With advanced age, they observed a 10 to 22% greater perfused boundary region in mice and humans, indicating a more penetrable glycocalyx. Compared with young, the perfused microvascular density was 16 to 20%, 21% lower, and red blood cell fraction was 5 to 14% lower in older mice and in older humans. These data provide novel evidence that across mammalian species, a diminished glycocalyx is present in advanced age and is accompanied by markers of impaired microvascular perfusion. Et al. Evaluated elevated palmitate, an independent risk factor of cardiovascular disease, in endothelial cell senescence. They discovered a key role of double-stranded RNA-dependent protein kinase, PKR, in endothelial senescence. Exposure of human umbilical vein endothelial cells to elevated palmitate induced cell senescence characterized by increased levels of senescence-associated beta-galactose glucosidase activity, excessive reactive oxidant species production, impaired cellular proliferation, and G1 phase arrest. This phenomenon is associated with increases of PKR autophosphorylation and decrease. Thank you for watching the September edition of AJP Heart and Circulatory Physiology video table of contents. Just a reminder to our submitters that new requirements for reporting enhanced scientific rigor are or soon will be implemented. Watch for this and let us know if you have any questions. If you're near Omaha, by the way, or would like to come and hear excellent science presented by our associate and consulting editors on October 2nd, I invite you to go to our conference website shown below and register. It's free, and we'll see you next month. And don't forget to send us your best work now.